Hello, Keith Rucker here, VintageMachinery.org. Guys, got a little project I'm going to work on today. This one's going to be a little interesting, I think. A little turning job here on the lathe, for the most part anyway. But what I've got is, a while back I actually made some new stems for a pair of tri-cocks that go on a steam locomotive. And when I sent those back to the person that I was doing that job for, he went to put them back together. And he tightened this part up down here on the bottom. This is the bottom half of one of the tri-cocks. When he tightened it up, it snapped off a piece of threaded piece in here. That it was just a little bit, it's just old and thin profile, been gone through a lot of torque over the years, and it just snapped off. So what he has done is asked me if I could remake the bottom part of this tri-cock valve. And that's what we're going to be attempting to do today. It's going to be a little bit complicated in the fact that we got two threads on here. One of them is up against a very tight shoulder, which is going to be interesting to do on the lathe. But even more challenging, and something that I've quite honestly never done before, is we're going to be turning tapered threads. So the threads on here are boiler tap threads. They're, I think it's 12 threads per inch, but it's on a 3/4 inch per foot taper. Same taper that you have on pipe threads, but on boiler threads, they basically are just a really long stretch of possible sizes that these things can fit up into. Anyway, we're going to be doing that over on the lathe, and that's going to be the game plan. Let me zoom you in here, show you what we got. I got a piece of brass stock here we're going to make a new piece out of, and we'll go over the lathe and get started. So here's what we're dealing with, and again, this is kind of all the components here. The top part of this is fine. This is the new valve stem that I made previously in a video a while back. The top part here, while being galled up with a pipe wrench over the years, there's really nothing wrong with that. Basically, this bottom piece here is what this threads down onto. It threads down on that thread there. I think it was 1 1/8". 7. I'll double check that again later when we get ready to turn it. But this part down here snapped off, and actually if you look, you can tell where even this tapered threads on here, it looks like it had been bent or cocked a little bit at one time. So we're going to remake this bottom section. Going to have the threads on this side, tapered threads, this side up here. We'll turn that down. It's got to be cut down the inside and have a matching seat for that valve to go close up in there. And then we'll have to cross drill, and this is just a pipe thread in here. This is just for a little nozzle that comes out of there, the steam comes out. This is used to manually check the water level in a boiler, on a steam boiler. There's usually 3 of these, sometimes 2, sometimes 4. But there's several of them on the boiler, and what you can do is you can crack these valves, and depending on whether steam or water comes out of this hole right here, you can manually determine the water level of the boiler. There's a sight glass on there to visually be able to do that, but if something were to happen to that sight glass, this is kind of the backup system to manually be able to check water height in a boiler, which is extremely important when you're operating a boiler. If you let the water level get too low, it can lead to a boiler explosion, which is never a good day. Enough on that. What we're going to do is go over here and get set up on the lathe and get ready to start making this part. I think what I'm going to do is we're going to turn the taper in first. Honestly, guys, that's where the most can go wrong in this project, so I want to get that knocked out first. Once we get that done, I think the rest of it will be fairly straightforward. So let's go over to the metal lathe, and we'll talk about how we're going to set up to do this. So I got this mounted up over in the lathe, and I want to go ahead and start kind of prepping this bottom end down here. We're going to turn, of course, the taper in first. I'm going to face the bottom. I think I'm just going to true this up in here, and then we will start getting our taper set so that we can actually turn that taper. So let's fire up the lathe. Start by facing the bottom. Mark on here about how far down I want to Clean that up too. And I'm just going to shave a little bit off of this right now. I'm just trying to get a surface that is running true to the spindle. So I think I've got my taper attachment set up back here, and in case you guys are not familiar with how a taper attachment works, if you look, we got this bar back here in the back, and it is set at an angle. There's a track in here, and basically it connects to my cross slide. I'm able to disconnect the screw, not really, it still can screw back and forth, but basically as it moves across this back here, it's going to move the compound along with that. So if you watch as it's coming in, I don't know if you can see it or not, but as it's coming toward me, it is moving the cross slide back at the same rate that that taper. It's actually riding on that taper back there. Notice the taper's standing still, and that allows us to cut a taper. All right, we should be ready to start going here. I'm gonna come on in. As it gets out there toward the back end, you're going to see the light getting lighter and lighter and lighter. Eventually it's going to run out. I'm going to feed in. We'll come back into the cut. And we are cutting that taper. Got a little bit of a taper turned on here, and I want to actually confirm that we're turning the taper we want to turn. So as you guys, I've already showed you, I'm using this little gauge that I made to kind of set the machine with. And the way I did that was I just literally laid it back here against this template that we're basically cutting against, and just lined it up against the casting down there. And that was to get me a rough setting. And now that I have got a little bit turned on here, I want to come in here and see where I'm at and see how close we really are and see where we need to go from there. Now, to check and measure this taper, what I'm going to use is a taper micrometer. Now, this tool is set up where you basically have 2 points on this side, 2 points on this side. This is a sine bar for all intent purposes. You can use that to measure angles with by using some trigonometry. We're basically figuring out with this. So, you know, when these measurements, this measurement here reads 0, is straight, it's perfectly flat. We're measuring the distance from flat up here. You can think of that as a right triangle, and you can use a sine function, which is why they call it a sine bar, to determine the angle, or in this case, the taper. Now, because of what we're doing is a taper, where it's inches per foot, this gets really easy because this is exactly 1 inch between these 2 pins. So I know that if I'm at 3/4 of an inch per foot is my taper, I can divide that by 12, and it comes out to 0.0625 inches per inch is your taper. So we should be able to come in here with this tool. We kind of come in here, and you get the bottom end where it's touching. You get the, basically you want both of these to touch, and you want both of these to touch. We come in here, we get a measurement, and I read that measurement, and it should be what we've got over there. And I'm going to double check this. Yes, it's measuring what I got a while ago. All right, I've come in here with my taper micrometer. I've measured that measurement, and the measurement I'm getting is 0.120. So the difference in the height from 0 is 120 thousandths of an inch. And we're shooting for a taper of 3/4 of an inch per foot. That comes out to 0.0625 thousandths per inch. Now, because this is an included taper, in other words, when I'm measuring this, I'm measuring the taper on both sides. When we say 3/4 inch per foot, that's off of the center of this. So we have to double that. That's 125 thousandths is what it should be reading if it's correct. So basically, my taper is off. On the included taper is off 5 thousandths of an inch per inch, or on one side 2.5 thousandths per inch. Okay, so what I want to do now is figure out how far do I need to move this back here to make up that difference. So I've gone back, and from the center to this mark right here of this bar, the pivot point to that bar, that's 12 inches. So again, I need to take that 2.5 thousandths, and because we're going out 12 inches, that's taper per foot on one side, because this taper here is half of the included angle. I need to move this times 12 that, which is going to be 30 thousandths of an inch. I hope that makes sense. Basically, just so you can see it, here's the math. There's what I did. I was shooting for 125. I got 120. That leaves me 5 thousandths. That's the included angle, so I divide that by 2. That gives me 2.5 thou. Multiply that times 12, because I'm coming out 12 inches on that sign bar, or that taper bar back there. I need to move it 30 thousandths of an inch, and we should have it exactly right. And it does need to get larger, so it needs to move away from me. Let me go get some wrenches, and we'll go back there and see if we can dial that bar in. The needle comes toward me, it's moving this way. I want to go away from me, so the dial needs to move in this direction. I'm going to loosen these up. Loosen this one up. And now, just loosening it, moved it a couple of thou. I can adjust it right there. There's 30 thousandths, which is what I want to go to. And all right, that didn't move. I figured whenever I tightened it up, that would move. All right, that should have my taper fine adjustment made in there. I'll clean that off, make a pass or two. We'll recheck it with the taper micrometer and make sure we're right on the money. We should be. All right, we're just making our pass down through here. So that should be cleaned up now with the new taper. I'll get my taper micrometer back out. I'm going to be honest with you, when I made the first adjustment a while ago, I went in the wrong direction. So I had to move it back 60 thousandths to actually take up what we did wrong, plus compensate for what we should have dialed in to begin with. And if this measure is the same, I should be right on the money. Let's get a good measurement here. This thing can be a little bit aggravating. All right. And we're shooting for 125, which should be 0 on the dial there. And all right, so we are, according to that, 3/10 thousandths of an inch over. I can live with that. We have our taper set though. Now that we have our taper set, it's just a matter of turning that taper in there and getting it down to the dimensions we want. So we'll turn it away. Basically, we're going to do this just like we were turning it straight. Just take a little bit at a time until we get down there. I'm probably going to just turn it up to about where we've got it going right here, right now. And then I'll have to kind of transition this area in between after we get the taper in there. But that's kind of the end of my taper. And anyway, we'll freehand that in or something, put a different angle on that to transition between there. Let's fire up and get to going. Start taking some little bit heavier cuts here now that I got my angle set where I want. We'll get those cut on through this. I'm going to go to that shoulder right there. Take another pass. pass. All right, I went ahead and finished turning this out. I put a little chamfer in there. It's just a 45-degree angle going down to the taper. I've got this set up now to do 12 threads per inch, and I want to just do a little scratch pass on here to make sure I've got everything set up exactly where I want it to be on 12. And let me just make sure, double check all my settings here. I think we're about ready. So let's engage this. So let's engage this. We're going to go out to that line right there and just back out. I want to check that with my thread pitch gauge. We're on 12. That's good. Let's start cutting some threads. You can see it's following the taper just like we were cutting with it a while ago. And cutting threads here is going to be exactly the same as it would for anything else. But instead of going flat across it, we're cutting it at a taper. I'm basically just doing these until I get a sharp point up on the top because of the way this taper works. There's really not a test fit here. I'm just doing a scratch pass here. I actually like that. That looks good right there. I think we're going to call that good. All right. I think we're ready to go ahead and part this tool off, or this part off, and we'll turn it around and finish on the other side. So I've got a mark there where I want to cut it. Let's get this lathe fired up. And we'll just push this parting tool down through there. Got my part turned around backwards in here now. We're going to work on this side, and basically you need to turn it down. This is an 1.1 inch diameter. I got a mark on there about how deep we need to go, and get that, and then we'll have to thread it. So let's come in here, touch off. Let's get this turned out. Fuzz it. We were Need to take off about 2 thou. And that's reading right on the money. All right, good job. Let me face the bottom of that. And I want to face this surface here too. Okay. This next step here is cutting these threads. These are 7 threads per inch. Pretty coarse, pretty deep threads. And to make it even more fun, we're going to go up against the blind shoulder here, which is going to make sure that I have to stop it and pull out of there as quick as I can when I get down there to the end. So I've got the lathe slowed down pretty slow, but as you can see, when we engage the half nut, it's making a pretty good run down through there. Of course, I got it taken out of taper mode and all that kind of stuff right now. So I'll tell you what, let's go in here. We're going to touch off. I'm going to do a scratch pass here. Make sure we're where we need to be. And that looks like 7 threads. All right. I won't make you guys watch all of this, but we will make our way down through there. All right, I'll bring you back when we get a little closer to the bottom. We're getting pretty close down here to the bottom. That is a little bit snug, but it's really, really close as well. So let me just take another thou or 2 out of there and we'll whittle it down in there. That's tight. Let's take about another thou out of there. We don't need much more. It was hitting in that root down there. It didn't hit the face, but I think this is probably going to be right where I need to be. Yeah, that I think is going to be good. Very nice. Got a little gap in there, but that's what we had before. That's bottoming out. I like the way that feels, so I think we're good. And that thread is just about perfect. All right, so next, need to work on that inside part there. Get that drilled out and get a seat down in the bottom that's at the right angle. Let me figure out what we need for that. Got a countersink on here. This is a 90-degree included angle. It matches the seat that will go down in there. So I'm basically just going to cut that seat down in there. Oops. So let me get that down in the bottom. There it is. And we'll cut that in there. And I believe that seat is going to work just fine. This, of course, will screw down in there, seat right down the bottom in that top piece. That's what will open and close the valve. So I think we're good to go there. Now my 1/4 inch hole is not all the way through. I'm going to leave this chucked up in the lathe until I can get a longer drill bit and get that done. But before I do anything else, I think what I want to do is go ahead. I'm going to screw this piece back on, and I want to just clean that up, get all that roughness off of it. It just looks bad, and we can do better than that. So we'll get us a tool here and just come in there and clean that up. Looks a lot better, and while I'm there, I'm just gonna chamfer the back of that with that cutter that's in there. There we go. Break that sharp corner. You can definitely tell it's two different materials, but I think it'll be fine. I'm mixing up some lapping paste here. This is Time Saver. This is their coarse. And basically it's a powder. You mix it with a little bit of oil, make a paste. The nice thing about this Time Saver stuff is that it was made by or invented by the Navy, is what I was told back during World War II, where they could use it for lapping in propellers and stuff on ships. And if you didn't get it all cleaned out, it breaks down over time, so it's not a big deal. Which is nice in a lot of applications where you don't have to worry about getting it cleaned up. This one here, we could clean it up, wouldn't be a big deal, but hey, it's nice to use this stuff. And what I want to do is I just want to lap those two surfaces together. So we'll fire the lathe back up. I'll just feed them together down in that bottom. And we'll hit it a couple of times. I'm not sure how deep this is. All right, I'm just going to do that a couple of times, putting some fresh compound on there every time until I get a nice finish in there. Two good mating surfaces. All right, I feel pretty good about having a good seat down there now, and we'll go ahead and take this out. And I'm to the point now where I just need to get my longer drill bit before I want to take that out of the lathe. So I'm going to go ahead and get that ordered tonight, and we'll finish this video up once that comes in. Got my long drill bit in now. Ordered that from McMaster Car, came in. So we're going to go ahead and finish drilling this thing out. And I think we're through. Next thing we got is a little piece that's drilled and tapped kind of crossways to this. This is for a little nipple to come out that the steam actually comes out of. And that's tapped 1/4 inch, or excuse me, 1/8 inch national pipe thread, 1/8 inch 27. So that needs to be drilled with a letter S drill bit according to my drill chart. That's what I got in here. Go ahead and kind of spot that, get us place started. And we'll cross drill this. All right, there we go. We got a hole drilled through it. Got my tap in here with a tap follower going right down that same hole that we drilled there. And with a pipe tap, it's a tapered tap, and I actually put a mark on there. I actually screwed it down into the old original part to see how far it would go down. You see that black line, but that's how far I want to tap down to, which pretty much matches the depth of tap in the old one we had. That's it right there. And with that, I think we have this job finished. I've reassembled the tricock. Of course, here's the broken original piece, new piece we made for it, and refreshed up the old existing parts here and put it all back together. This should service them well, I do believe. You know, one thing I've thought about doing was milling some slots in here to put some wrenches on this, but he told me he wanted to leave it like it was, but just keep it original. Why they made it where you had to use a pipe wrench, I'll never know, but that's the way they did it, and he wants to leave it like it is, so that's what we're going to do. But anyway, there you go. Turning tapered threads, machining brass, doing a couple of threads on the lathe, a nice little project here, nice little fun little project, and I think this is going to work out just fine for them. Only thing I wish that we could have done a little bit different was match the brass here. In the long run, I don't think it would really matter. This brass down here is what's rated for doing with steam fittings and so forth, which is why I purchased this particular grade. I don't remember which one it is, but obviously it's a little bit different alloy between the two. But hey, no big deal. It's gonna work just fine. And just like that, another job knocked out here. We'll get this back over to our gentleman that we did this project for, and he can hopefully get it back on the locomotive and have it going, and another project finished here in the shop. As always, guys, thanks for watching. Please subscribe to the channel if you haven't already. Thumbs up are appreciated on these videos. And with that, we'll catch you on the next video.